Hi everyone, today we're going to be looking at the BRX Do-More PLC Modbus ASCII protocol. Now, detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. So the first thing we'll do is take a look at the SOLO standard temperature controller, which always comes with the Modbus RTU and Modbus ASCII protocol. And Modbus is a communication method used for transmitting information over serial lines between electronic devices. And the serial lines are usually RS-232 or RS-45. Now today we're going to be connecting a BRX Do-More PLC to the SOLO process temperature controller, and this is going to be using the Modbus ASCII protocol over serial RS-45, and we're going to read the present value or the PV value, the set value or SV value from the SOLO controller, and then the set value will be written back to the SOLO process temperature controller. So up on my screen here, you'll see that these are the standard SOLO temperature controllers, and they come in very different DIN sizes that are available. And if we look at the manual for that controller, we will see that in Chapter 3, when we call that up, we will actually show you that there are the indications, and we have a method of setting up that temperature controller that you see right here. And also, if we go back to the controller and look at Chapter 7, this is where the Modbus communication comes in. And with the Modbus communication, this will show us the addresses. There's my Modbus RTU and Modbus ASCII that's available. And we can have up to 247 different controllers communicating on the same network. And there's my registers, and the online configuration parameter, which is the COSH, must be set, which we'll see that in a minute. But here are my addresses that we will be looking at, and my process value or present value, PV, is at hexadecimal address 1000, and my set value or set point value is at address hexadecimal 1001. So there are two consecutive ones here. So that's what we're going to be looking at. So next, let's take a look at the physical hardware that we have here. And there we go. So this is my BRX PLC. It's the BX-DM1E-18ED13. And you can see here that I have my RS-45 port and RS-232 port, depending on how you configure it, which we will take a look at. And then we have our Ethernet that we're actually communicating back to our software. So from here, we are communicating the RS-45. It's connected into my SOLO process temperature controller. And we also have a thermocouple down here that's actually connected that we can measure what the present value or present temperature is currently, which is 25.1 degrees Celsius. Our set point currently is 123.4. So that is my setup. So if we take a look at the actual program, and this is the Do-More designer software, the first thing we'll do is the first thing we'll do is actually set up the SOLO, make sure that we have the parameter set. So the first thing we'll do is take a look at the SOLO. We'll go into the programming part. There's the J-type thermocouple, degrees temperature, Celsius, upper and lower values, control, PID, heat, alarm 1, 2, 3. And now what we want to do is go into this remote access, and you see that now that it is on. This is what we wanted. We have our communication media, which is set for Modbus ASCII, which is what we want. We have the unit number of 1. We have the baud rate at 19,200. We have the length of 7. We have an even parity. We have 1 stop bit. And then we're back to the J. So those parameters that we just set there must be equal to the same parameters we set on our Do-More designer software to program this, or our BRX PLC. So the first thing we'll do here is go into the PLC, and we'll go to the system configuration. And under system configuration, you'll see here that my serial port configuration and our protocol, we are going to set for stream in and stream out. So what that allows us to do, you'll notice that Modbus RTU server and client are already in the PLC protocol selection. However, because we want to use the Modbus ASCII, we're going to create this within the ladder logic. So we're going to select the stream in, stream out for ASCII and custom protocols, and this is going to be a custom protocol that we're going to be doing. Then we want to select the port type, which is RS485, and we will click on the enable the 120 ohm termination. And if we look at the parameters, we change the parameters here. You'll see that we have 19,200 for the baud rate, 7 data bits, 1 stop bit, even parity. And this matches exactly what we just shown on the SOLO, and it's important that they do match. The transmission control is left unchanged at unconditional, and RTS control follows transmitter. So we'll just hit cancel out that one. So that is our system configuration. Hit OK. And now let's take a look at the actual program that we have here. So over here we have our main program, and then we have a further program called Modbus ASCII, BRX to SOLO. And so here's our main program here, and what we're going to do is we're going to communicate to the SOLO. The V1 is going to show us our present value, and our V2 is going to be showing our set value. And if we want to change the set value, we'll put in V10, the changed value that we want to set the SOLO to. So if we look now at the Modbus ASCII, here we go. As soon as we call it up, and you see that we do that all the time in our main control. So this is running every scan. And Modbus ASCII protocol starts with a start character, which is the colon sign. Then we have our slave number, which is 01. Our unit number, which is 01, which we've shown on the SOLO. Our command code, which is 03, which is read multiple registers. Our starting register is 1000 that we saw on our ASCII Modbus manual in our SOLO, where the addresses are. And we want to read 2 registers, which gives me my present value and set value. And then so that's what our command is going to be. So our screen print or string print, strprnt, will actually allow us to enter that value into register SS0. And if we just call that up, you can see that this is exactly what it's allowing us to do. So I'm actually putting in the colon and then the unit number and putting exactly what I want to put out of the port. The EA then is my what we call our LRC, which is longitudinal redundancy check. And what that is a calculation that we will do later on when we have to write, because we'll have variables. Then we have our termination, which is OD, OA, which is our carriage return and line feed. And that will terminate the information and tell the Modbus ASCII what we're looking for, and that this is the end of the message. Then next, what we'll do is during the first scan, or we have this start comm again, we will actually stream out the information. And so what this is doing is opening up our port, our serial port, and then we'll send that stream of information out of SS1 out of the port to the SOLO. And if it's successful, it'll turn on the success bit. And if there's an error, it'll turn on the error bit. Next, what we'll do is stream in. And once we stream in, we will get that information back. Now, what we're receiving back actually is almost a replicate of what we actually streamed out. So our start character will be the colon. Then we will receive our unit number, or our slave unit number, which is 01. We'll receive our command code, which is 03. Then we'll receive the number of bytes times 2 for the referencing, because it's ASCII. So it's twice as much as what we need. So in our case here, we'll receive 4. So that means that the next 8 characters will be the data that we're looking for. So the first 4 will be our present value, and the next 4 will be our set value. Then we have our LRC. And you will see here that we have selected in our stream in our delimiter sequence, which is again ODOA, which is the carriage return line feed. The next thing we do, once we received a good message and the ASCII has come in, then what we want to do is then split that ASCII out into our variables. So in our case here, we're taking the string coming in, we're starting out the 7th character, and we're reading 4 characters into SS2. Then we're taking SS2 and we're converting that using the string to integer into a hexadecimal number. Then we can actually read what the value is. In our case here, we're currently reading 254, which is actually our present value. So that's our present value that we've currently read from that controller. Then our next one, we're taking the same string. We're taking an 11th character now, which is 4 more than the previous, getting 4 more, and then converting it from the string to integer, which gives us a value of 1234, which is 123.4, which is exactly what we're seeing on our SOLO. So again, the reading looks like it's doing well. Then what we do is we have to then take a look at the calculation of our LRC. And what that is the LRC is the calculation of adding together successful 8-bit bytes in the message, discarding any carries, then to complement the result. So our Modbus ASCII SV write is going to be colon 01061001, and then the value we're going to write to, and then our LRC number. So that is our string character coming out. So what we do is we discard the starting character, we take the 01 plus the 06 plus the 10 plus the 01 gives us the value of 18. Then what we do is take the first 2 digits of our least significant bit and our most significant of our set value, and we add those to that 18 in hexadecimal. And then the formula is actually 1 minus that number, and then minus 1 to actually add 1 again, and then the results convert into the ASCII text. So that's actually the math that we're going to be using. So if we look at the math instruction, again, we're doing this, we're taking our SOLO set value change, and we're masking the first 8 bits, so we only receive 8 bits, and then we're adding that also to the SOLO set value change, and we're shifting the over 8 bits, so it gives us the least or the most significant bits. Then we're doing all that addition. So we take the 1 minus all this, then we actually minus 1 more, and it gives us our LRC value. Then what we do is use the memory copy or mem copy to then copy only the last 8 bits, because that's what our LRC will be, and it will copy it into our LRC value, which is going to be done in hexadecimal. Then what we do is we use the print string again, and we're going to print string to SS11. This will now give us our actual value that we're going to be writing out to out to the controller. So if we double click on it, you can see here, again, we're going to set up our string, which is going to be the colon, 01, unit number, 06, we're going to write to register, and the register address is going to be 1001, which is our set value. Then we're going to format our integer. Now V11 will contain our value that we want to change it to, and we're going to convert it to hex. Now it's in hex. We have 4 digits and we want 0 padding, so any leading zeros will add to that to create the 4 digits that we're sending. Then we're going to take our checksum, or our LRC, and our LRC will then be calculated or formatted using the format integer. We're going to take that from 21 that we just did, those 8 bits that we scooped off. It's in a hex format. We have 2 digits, and again, 0 pad if we only have 1 digit. And then we add our carriage return line feed on the end of this in order to terminate that transmission. Okay. So then once we have that set up and we need to write that value, what we'll do is we'll stream this out of the port. And we stream out with the port, we then turn on C4 or C5, depending on whether it's successful or not. If it is successful, we'll stream back in the information. Then what we do is if we're writing, then we'll copy 0 back into our writes, indicate that we have done the write command for us. And then we will set our end of communication bit, which is this C8. If we are not writing, then what we'll do is we will set our end of communication bit. Then our end of communication bit, we've set up a 20 millisecond timer, and that 20 millisecond timer will then trigger C9, which then will communicate back to the beginning of the information all again. And then what we have is our end of communication bit is on. We check to see if we need to write in the next communication segment. If we do, then we copy our write value into our change value, and then we set C10, which indicates that we are going to write to the SOLO process temperature controller. And that's the end of our program. And you can see up here, that C9 started COM again, we'll start streaming again. So basically we want to watch the timing because we want to check only after we finished all our communication whether we need to do that writing again, so that when we start communication again, we know exactly what we're doing in that order of sequence. So let's just call up our data monitor. And what I'm going to do is just drag it over here. And you can see here that I have my SOLO present value at 255, my SOLO set value at 1, 2, 3, 4, and my SOLO write value here. And so again, these figures right now are reading all the time. Every 20 milliseconds we're updating, and we're getting new values in for this information here. So if I were to hold the temperature controller, you can see that my temperature now goes up, and you can see the corresponding number here going up as well. Let go of it. Now it's at 29.4, and you'll see the corresponding 29.4 here. If I need to write something, we'll put in the value 300, and keep in mind the decimal point is actually already inherent within that number, right? And you can see automatically it goes into the set value, and we see it on our SOLO immediately. So the response is very quick. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.